Once again, hearty welcome to the video series on math revision made meticulous. In determinant topics, we will see application of matrices and determinants. Revision, as the name suggests, means looking back over previously learned information, ensuring that it is clear and fresh in the mind. 5 questions per video from selected topic is presented in this video series. The steps in answering are supported by the ideas used for getting the answer. Let us see what do you mean by consistency of system of linear equation. Already you have seen it in lower class, but anyway we will recollect it once again. Consistent means a system of equation is said to be consistent if it has solution, one or more. Suppose if it has unique or many, it will come under consistent. Inconsistent means a system of equation is said to be inconsistent if its solution does not exist. Where you already seen it in class 10, a system can have unique solution, many solution or no solution. Unique and many comes under consistent, no means inconsistent. That's all. Well, let us go to the solution of the linear equation using inverse of a matrix. Already we have seen the solution using a lot of methods in lower class, graphical method, and you have seen substitution method, elimination method, cross multiplication method. Here we are going to use inverse method, which we can use it for linear equation in 2 variable and linear equation 3 variables also. A system of linear equation can be expressed as matrix equation and can be solved using the inverse idea. Let us see what is the solution now. Consider the system now. A1x plus b1y is equal to c1, a2x plus b2y is equal to c2. Normally, whenever we are any equation is given, we will try to convert the constant to the right hand side because we are going to take a separate matrix for that. Well, I will take first matrix as A, which is obtained from the coefficients a1 b1 a2 b2. Then capital X is a variable matrix which is x comma y, which is 2 cross 1. Then B is c1 c2, which is called RHS matrix or constant matrix, whatever you call it, is c1 c2 once again 2 cross 2 rows and 1 column. Why we are taking like this? Then only product of A x will be B. You are going to see. Then the system will become, when you multiply it, first one is 2 cross 2, second one is 2 cross 1, our final answer is 2 cross 1. When you expand it, it will become A1x plus B1y, A2x plus B2y will be the left hand side matrix. You can equate it to C1 and C2. That's all. Therefore, AX is equal to B is the matrix representation of a system of linear equation. Let us move on to the having 3 variables now. Same idea. What is A? It will be the matrix obtained from the coefficients of x, y, z. Finish. Capital X is the matrix which is obtained from the variables. Capital B is the matrix obtained from the right hand side numbers d1, d2, d3. Same thing. It can be written like this now. Multiplication of the 2 matrix will be the third one. Therefore, AX is equal to B. Therefore, we are now able to express the given system of linear equation, whether it is 2 variable or 3 variable, as matrix AX is equal to B, where capital A is the coefficient matrix, capital X is the variable matrix, and capital B is the right hand side number matrix. Well, now how to get the solution now? Suppose you assume that A is a non-singular, A inverse exists, AX is equal to B, pre-multiply with A inverse, then A inverse A is I, therefore by associative property I am using Ix is equal to A inverse B. All of you know I is an identity matrix, therefore Ix is X, therefore X is equal to A inverse B. No need to write all these things in the exam. You have to remember that when Ax is equal to B, X is equal to A inverse B. This matrix equation gives unique solution to the system of linear equation provided A is a non-singular matrix. Well, now A is non-singular, then determinant A is not 0. We calculate adjoint A. Then if adjoint A into B is 0, then the system will have infinite solution. Suppose now we are going to discuss what will happen if determinant A is 0. Definitely we cannot find A inverse. In that case, we cannot tell that there is no solution directly. We have to find adjoint A into B. We can find adjoint A. Because determinant A also we are not able to find. We can find adjoint A. Find adjoint A into B. If it is a 0 matrix, then the system will have infinite solution, that is many solution. If this adjoint A into B is non-zero, then the system will have no solution. Therefore, if adjoint A into B is 0, then it is consistent. If adjoint A into B is non-zero, it is inconsistent. Okay, Ax is equal to B. Let us see in a table, if determinant A is non-zero, then you conclude that X is A inverse B and it will consistent and has unique solution. Suppose if determinant A is 0, don't lose your heart, find adjoint A into B. If it is once again a 0 matrix, then the system is consistent and has many solutions. But if determinant A is 0 and adjoint B is non-zero, then no hope, the system is inconsistent and has no solution. Now all of you know what will happen in no solution, it will represent parallel lines. Anyway, in 2 dimension I am talking about. Anyway, now let us go to a question now. Just for example, now this is a system I have taken. What I have to do now? I have to find A, X and B. I am finding determinant A. It is non-zero, therefore I conclude that the system is consistent. Actually, without solving, we are simply telling the nature of the solution. This may be asked in 1 mark in your exam. That is simply tell whether it is consistent or not. Let us go to the next question now. Suppose I have found determinant A once again, but I am finding it as 0. But don't lose your heart. I am finding adjoint A. You know how to get the adjoint A. Interchange the elements of the row and then change the sign of the next diagonal. Therefore, I am finding adjoint into B. I am getting it as 0 once again. Fine. Therefore, this is consistent and has many solutions. Let us go to the next example. Suppose when I am finding determinant A, then it is 0. I am finding adjoint A and finding adjoint A into B. Oh, to my surprise, it is coming as 0, 30. Therefore, it is a non-zero matrix. Therefore, this matrix is inconsistent and has no solution. But very simple. Find the determinant A. If it is non-zero, unique solution. If it is 0, 2 cases. Adjoint A into B 0, it is consistent, many solution. Adjoint A into B non-zero, it is inconsistent and has no solution. Well, let us take one quick question. Examine the consistency of the system of equation. You have to check whether it is unique solution or many solution or no solution or simply consistency. I am taking this example and I know what is capital A and what is capital X and what is capital B, and I can write it as AX is equal to B. I am finding determinant A and I have to check whether this determinant A is a 0 or non-zero. I am expanding it with respect to the first row, 1 into 2 cross 2 minus 1 into a 2 cross 2 plus 1 into a 2 cross 2. I am expanding. I am getting the final answer as A. Final answer as A after expansion. But remember, in the equation, the last equation is AX plus AY plus 2AZ is equal to 4. Therefore, to be very clear that A is a non-zero quantity, otherwise the third equation will never exist. Therefore, this A is non-zero, therefore A inverse exists. Therefore, the system is consistent and has unique solution. You have been not asked to solve it, you have been asked to examine whether it is there is any hope for solving it or not. Well, let us go to the next question. Examine the consistency of this following system. It's a 3 cross 3. I am taking it once again. I am writing it as AX is equal to B. I am finding determinant A, expanding along C1. Why I am expanding with respect to C1? Because there is a 0 waiting there. Therefore, 3 into 2 cross 2, again plus 3 into 2 cross 2, because 0 into something no need to write. Don't get surprised that why I have written only 2 terms. 0 into something no need to write. Well, therefore I am getting the final answer as 0. Okay. Now, there is a hope. What you have to do now? You have to find adjoint A into B. Let us find. Therefore, it is singular matrix. A inverse does not exist. Now, we have to find adjoint A. For that, what you have to do? You have to find the cofactors. A11 is plus sign multiplied by a 2 cross 2 determinant obtained by removing the first row and the first column. Similarly, I am finding A12, finding A13, A21, A22, A23, A31, A32 and A33. Already we have discussed it in the previous videos how to do it. Let us go back to it values now. These values are Aij. Therefore, Aij. Therefore, adjoint A is equal to Aij the transpose. When I get the adjoint A, I am getting it as minus 5, 10, 5, minus 3, 6, 3 and minus 6, 12, 6. Therefore, when I multiply it with B, what I am getting? I am getting a non-zero matrix. If I get a non-zero matrix, what is the conclusion? The system is inconsistent and has no solution. Good. Let's go to the third question now. We are now going for problems where we have to solve. This will come for section D, maybe 5 mark question, where they will ask you to solve a system of equation given they can be directly given, or they can ask you A, find A inverse and use it. All of you know that A inverse A is nothing but the coefficient matrix. You are able to see it. But very quickly we will see. A is given. I am finding A inverse. I am finding determinant A. I am expanding with respect to R1. I am expanding it 2 into a 2 cross 2 minus 3 into a 2 cross 2 plus 10 into 2 cross 2. I am getting the final answer as 1200. Do it very carefully because the determinant A is going to decide the final answer. Well, now we are moving on to finding the cofactors now. For that, A11 is plus sign multiplied by a 2 cross 2 obtained by removing the row in which 2 lies and column in which the number 2 lies. Therefore, it is minus 6, 5, 9 and minus 20. I am getting A12, getting A13, getting A21, getting A22, getting A23, getting A31, getting A32, getting A33, Aij I am getting. This is nothing but the cofactor matrix. How to get the adjoint? Transpose of cofactor. For this is adjoint A. Now how to get the A inverse? It is 1 by determinant A into adjoint. Therefore I have written it over there. Don't try to bring the 1200 inside. It is of no use. Okay. Now the given system is like this. How to write? Capital A is nothing but the coefficient matrix. Capital X is the variable matrix. Capital B as the right hand side matrix. All of you can take that 1 by X as A, B, C. You can do no objection in that. Or capital X, capital Y, capital S also you can take no objection. The matrix equation is Ax is equal to B. Therefore A inverse B. X is equal to A inverse B. Already A inverse I have obtained. Put it over there. After the calculation, bring that 1200 inside. Don't bring it now. Then it will become 1 by 2 minus 1 by 3, 1 by 5. Therefore, 1 by X is 1 by 2. 1 by Y is minus 1 by 3. 1 by Z is 1 by 5. Therefore, X is 2, Y is minus 3 and Z is 5. A little bit lengthy, but be careful in doing the problem. After you have completed the values of X, Y, Z, better put it in any of the equation and then check whether you are correct. Well, now let us go to question number 4. These types of problems are started coming in CBSE where they are asking you to use a product and then solve it something. That product gives you a clear idea. Whenever they ask like this, use the product or find AB, then solve, always keep it in mind that the idea which you are obtaining from the product to be used for solving. In most of the cases, be happy whenever they give you a product like this, there is no need to find the cofactors, there is no need to find the inverse and so on. You are going to get directly from the given idea. So keep it in mind. I have seen children finding the product separately and taking the solution separately and then again finding the cofactor, again finding determinant, and then they are just wasting time. Again I repeat, the product to be done, from that infer the idea and then go for solving it. Now let us now go for this question now. A is given, B is given. I find AB. Oh, to my surprise I am getting it as a identity. What will happen when AB is identity? Very simple. A and B are inverse to each other. Therefore, what they have done now, they have already given you A inverse. A inverse is given to you there. Okay, therefore AB is there. Therefore, which means that AB is I. Therefore, B is nothing but A inverse. Therefore, I got A inverse directly now. If I take first matrix as A, second matrix will be A inverse. If I take the second matrix as A, first matrix will be A inverse. No problem. But I will take the first matrix as A with a purpose. What is the purpose? Because you are having the system. This system is having the coefficient as 1, minus 1, 2, 0, 2, minus 3, 3, minus 2, 4, which is nothing but the matrix obtained from A. Therefore, I take this as A and B as A inverse. Good. Therefore, A I am making and X I am making and B I am taking. Therefore, the matrix is Ax is equal to B, X is equal to A inverse B. Are you having A inverse B with you now? Yes, A inverse is with you now. Therefore, directly substitute it and finish the problem now. About the value of X is 0, value of Y is 5, value of Z is 3. Once again, I repeat, if they ask you to do a product and then solve a system, be careful, find the product, get the information and directly go for solving the given system. Good. Let us move on to the next question. Question number 5. Here A and B are given. You have to multiply and hence you have to solve the system. Don't take it as two separate problems. In the previous problem, when I multiplied the given two matrices, I got a identity. Let us check what we are going to get in this problem. A is given, B is given. AB I am finding. To my surprise, I got it as minus 8, 0, 0, 0 minus 8, 0, 0, 0 minus 8. Fantastic. For what I have to do now, I have to take minus 8 outside. When I take minus 8 outside, I am getting it as an identity matrix, for it is minus 8i. Previously, it was I in problem number 4, it is minus 8 into I. Okay, let us now look back. A property we have seen, that is, if A is a square matrix, then A into adjoint A is equal to adjoint A into A is equal to determinant A into I. Now just to connect it with this, A multiply by adjoint A is equal to determinant A into I. Now connect it, you will get AB is equal to minus 8i, which tells me that determinant A is minus 8, which is on the right hand side, and this B is nothing but adjoint. In the previous problem, the B was A inverse, but here the B is nothing but adjoint. Be careful with that. Well, now I think no need to calculate anything in this problem, because I have determinant, I have adjoint. Therefore, I will take what is A, what is X, what is B. I write Ax is equal to B, X is equal to A inverse B. I know what is A inverse, 1 by determinant A into adjoint, for 1 by minus 8 into the adjoint. Well, now I have A inverse with me, I have B with me, multiply, X is equal to A inverse B. Therefore, when I multiply, I get inside as 1 by 2, 3 by 2 and minus 1. Therefore, X is 1 by 2, Y is 3 by 2, Z is minus 1. Therefore, whenever they are asking you to find the product of two matrices and then continue, be careful. The product of the two matrices may be an identity. The product of the two matrices may be a scalar multiplied by identity. Thank you. Success is dependent on efforts. All the best.